So 7.1 day 2, finding the inverse of a function. So when you're finding the inverse of a function, you're going to switch your x and your y, and then you're going to solve for y. So today you're actually doing two things, okay? You're not only finding the inverse, you're also stating the domain and range, okay? So before you go any further, what I like to do is I always find the domain and range of the initial, okay? That way I automatically have the domain and range of the later part, okay? So if we have 3 cosine of x plus 1, what does the 3 do to our function? It stretches it by 3, right? Okay, so it goes from being 1 to negative 1 to 3 to negative 3, and then the plus 1 does what to it? Moves it up 1, right? So it goes from 4 to negative 2, correct? Okay, so our graph of cosine of x, so originally cosine looks like this, correct? Where this is that pi over 2, and then negative pi over 2 would actually hit at the same spot, but on the other side of that hump. Okay? Because cosine would start repeating. Okay, so is everyone okay how I figured out that it was going to hit, that this is going to be the section of the graph that I'm looking at? Is everyone okay with that? Okay. The hump repeats. So cosine starts like this, correct? So then it's going to repeat backwards. So where this hits pi over 2, this is going to hit negative pi over 2. Where pi hits over here, negative pi is going to hit in the same spot over here. Okay? It repeats this over and over going the other direction. And then we have to know what negative pi over 2 is because that's the original domain that they give us. Okay? So original domain we have to deal with. So the only part of this graph that we're dealing with is this hump here. Because that's what it tells us we're going between. We're going from negative pi over 2 to pi over 2. We know it's going to stretch 3. So instead of hitting at 1, it's going to go all the way up to 3. Okay? And then we know that it's going to go up 1. So then we know that it's going to go from here to here, like so. That your points are all going to shift up 1. So these two shifted up 1. The hump in the middle shifted up 1. Does everyone see how it all shifted up 1 after we stretched it? Yes? Okay. So it says find the inverse of the function. We haven't done that yet. But it also says find the range of f and the domain and range of f to the negative 1. So what would the range of f be? It goes from 1 to 4, because this is 1, 2, 3, 4. So my range of f goes from 1 is less than or equal to f of x is less than or equal to 4. The reason I put it in this notation is because that's the notation they gave us here. If they had had bracket negative pi over 2, comma, pi over 2 bracket, we would have put it in bracket form. Yep, they will give you the domain. They'll ask you to find the range, which is what we just did, by graphing that and picking out the section we needed. Okay, and then it wants us to find the domain and range of the inverse. If you have the domain and range of your regular function, what does the inverse do to that domain and range? It switches it. Okay, because remember, inverses switch your x and your y. Your domain is your x values. So now those are going to become your y values. Your range is your original y values. So if we switch them, this is going to become my x values. Okay, so our domain of the inverse of f, these switch. So now this is going to be my range of my inverse. This is going to be the domain of my inverse. Your domain and range switch, just like your x and y switched. So your domain would be 1 is less than or equal to the inverse is less than or equal to 4. And your range is going to be that negative pi over 2 is less than or equal to, oh, I have these backwards. This should have been x. This would be the inverse. Sorry. Because your domain involves your x values. Since it's your inverse, your range and domain flip. So your domain is this, but with x in it. Your range is that, but with the inverse function in it. This would be a multiple choice question on the test. Okay? So if you can't remember what goes in the middle, remember they switch, and domain always has to have x in it. This is our answer so far. So this is the answer to this part. We haven't even done this part yet. Okay, so this is the answer to part 2. And we haven't even done part 1 yet. We haven't found the inverse of the function yet. All we found was, we found the range and the domain and range of the inverse so far. So now we need to find the inverse function. Inverse means you're going to switch your x and your y. This is technically y, correct? So if we switch x and y, we get x equals 3 cosine of y plus 1. When you are solving equations and functions, you do PEMDAS backwards. So we need to add and subtract things first. What are we going to add or subtract? The 1. You're going to subtract 1 from each side. X minus 1 equals 3 cosine of y. We're still doing PEMDAS backwards. So we need to multiply or divide next. What are we going to multiply or divide by? 3 divided by 3. So we have x minus 1 over 3 equals cosine of y. Cosine is considered a parenthesis or an exponent level. How do you get rid of a cosine? The inverse. So you do cos inverse. So y equals cos inverse of x minus 1 over 3. That would be your equation of your inverse. No, this is a completely different type of question. Yep. Okay, so let's reiterate what this question entailed. It said find the inverse of the function, find the range of f, and the domain and range of f. Okay, I started out with the second part first because I know it gave me my domain here. I graphed it to find my range. After I graphed it to find my range, I wrote down my range. Okay? Now that I have my domain and range of my original, since an inverse is when x and y switch, it means my domain and range are going to switch. So now my range is my domain of my inverse. My domain is the range of my inverse. They switched just like x and y switched. Once I figured out my domain and range, then I found the inverse function. And I would recommend doing it in that order. I think this is part A, and then this might be B and C or something like that. But I like to do it in that order. Domain and range, then go ahead and find my inverse function. What overall questions do you have on this type of problem that you're going to see today? F of x is technically y, yes. Yes. So to find your inverse function, you switch your x and your y. You always have to solve to get y by itself, to get your true inverse equation, or your function. Because I graphed cosine. I knew that 3 made my amplitude 3, so I knew that it made it go from 1 to 3. And then this plus 1 means it all shifts up 1. So then the 3 has to go to 4. These that were at 0 have to go to 1. Yes? I don't think it compresses. No. And I don't think it changes the period on you either. Okay? I think it just does the moving up and down and the amplitude. Okay? I might be wrong, but I don't think it goes that in depth. Other questions? All right. So then the other type of function you're going to see today is it's going to ask you to solve equations. Okay? This goes back to what we did last Friday. So if you weren't here last Friday and you didn't watch the video of the notes, you're probably not going to understand what I'm talking about. Okay? So, if we're solving our equation, we first have to get rid of this 2, correct? So what are you going to divide each side by? 2. So if I divide this by 2, and I'm going to write it like this, that's the same thing as multiplying by 1/2, correct? And so you're looking where cosine inverse of x equals pi over 4. Where does cosine equal pi over 4? Or what does cosine equal at pi over 4? Actually, I should say. So 45. Okay. So cosine at pi over 4 would be a 45-degree angle, correct? What's across from 45? 1. This side would be 1 as well, right? What's this part? Square root of 2. What is the cosine of that angle? 1 over square root 2, right? Adjacent over hypotenuse. Okay, so you're at 1 over square root of 2, which would be square root of 2 over 2, correct? You times by square root of 2. You don't want that square root on bottom. So square root of 2 over 2 would be your answer. Yep. Well, it's cosine inverse. So you're not inverting it. It's the inverse notation. It's not switching fraction. I understand what you're... It's not flipping things. It's inverting. So to get rid of an inverse, you would do regular cosine of each side. So then this gets you x equals the cosine of pi over 4. Yes. So what we were doing last week was they were saying find the cosine inverse of square root 2 over 2. So they were giving you what was plugged in, and you had to tell me it was pi over 4. So it's kind of backwards what we did on Friday. What do you mean? Yeah, so last week they gave us this. We said the answer was pi over 4 or 180 divided by 4, which is 45. So that's where we just gave both the degree and the radian measure. So
Oh yeah, that's right. So the square root of 2 over 2 became the cosine, right?
Mhm. Yeah. Caitlin. So you're going to use the graph when it's like 1, 0, okay? You do the triangle when it's things like pi over 4, pi over 6, pi over 3, that kind of stuff. So when it's whole numbers, use the graph. 1, 0, -1. If you get cosine x equals 1. 1 is a whole number, right? Yeah. So then you would use the graph. If you get cosine x equals square root of 2 over 2, is that a whole number? No. So then I would use the angle that matches square root of 2 over 2, which is 45. So 1/2, anything with like 1/2 or square root of 3's is the 30, 60, 90. Square root of 2 over 2 is the 45, 45, 90. Other questions? Okay, so let's go on and let's talk about this one here. So I have 5 sine inverse of x minus pi over 2 equals 2 sine inverse of x. Okay? Close. I have 5 sine inverses here. I have 2 here. So how many am I left with? Then I'm left with 3. Yep. Becca, that's exactly what you would do first. So the first thing you would do to this one is you would get your sine inverses together. So then on this side, you're just left with negative pi over 2. On this side, it's negative 3 sine inverse of x is left. You do, because once you divide by the negative, you see how the negatives would cancel. But if you brought this over here, you'd have to do an extra step to bring it back over. So I would do it this way. Okay, so then you would divide by negative 3, correct? And again, I would write it as divide by negative 3. I wouldn't do the slash because I have a fraction over here. So negative pi over 2 divided by negative 3 is the same thing as timesing by negative 1/3. That's going to equal negative sine inverse of x because this 3 and this 3 cancel. So the negatives cancel. That turns positive, right? What's 2 times 3? The negatives? Yep. Yep. So you have pi over 6 equaling sine inverse of x. At pi over 6, what does sine equal? So pi over 6 is a 30-degree angle, meaning this is 1, 2, and this side is square root of 3. So what's the sine inverse of pi over 6? It'd be 1 over 2. Okay? If you want to make it easier on yourself, do it like this. Sine and sine inverse cancel, so you're looking for sine of pi over 6. And then hopefully, since you don't have that negative 1 anymore, you're not thinking as switching fractions. Okay? I kind of like that you're getting messed up on that because it means you know that a negative exponent switches your fraction. But with sine, it doesn't work that way, which is kind of messed up. Same with cosine, same with tan. Okay, it doesn't work. It's not a flip fraction. So maybe instead do sine of each side, and then maybe that'll help you stick in that mode of, I'm just finding the sine of this angle. Yep. Bryn. So on Friday, we did sine inverse of like this number. And so today, it's actually doing maybe what we did a couple chapters ago, chapter 6, of we're going to solve for x and find the sine. Yep. Because sine and sine inverse cancel. So I did that because people were getting messed up with the negative ones switching your fraction. That's not how it works with sine and cosine. Okay? So I think it'd just be easier if you got rid of the sine inverse by taking sine of each side. Mm-mm.